All right, so we are on part 3 of this video lecture in terms of our advanced manufacturing and producing products here. As far as we're going to talk a little bit about advanced processes. Uh, as we go into the future, one of the tenets of manufacturing is that you are always trying to improve on your production, improve your manufacturing processes, lower costs, try to get better, greater efficiency, and of course reduce waste. Um, these are all pretty much tenets of a lean manufacturing environment nowadays. And manufacturers, in order to stay competitive, have to be able to do this type of continuous improvement. So with that, manufacturers are constantly trying to do more with less. And as we sit here and talk about improving castings or molding processes or even forming processes, there is a concept called net shape manufacturing. This is where we can produce a product by using only one process. And if you think about it, a lot of things could possibly be done this way. Of course, 3D printing has kind of given us a leap in um, terms of developing this net shape manufacturing process. It's not quite there yet, but it could be in the future. Uh, and as we sit here and talk about net shape manufacturing, a couple of other terms pop up. One's called metal injection molding, and the other is called ceramic injection molding. If you think about a lot of your inserts that are made in the cutting tool industry now, as far as how we use inserts as opposed to high speed steel, a lot of these types of inserts are made either through metal injection molding or ceramic injection molding, where basically you get the part finished in just one process as well. As we get more and more into 3D printing using different types of powdered metals, it is possible that we could just use this one process as well. Although 3D printing is still a very time consuming process, so I don't know where that will lead in the future, but it's possible that that will be one of the key ways for us to get net shape manufacturing achieved in the future. Now, talking about 3D printing, we also need to talk about rapid prototyping. Rapid prototyping has been around for many, many years now, since the advent of 3D printing, and it's a way to produce physical properties or physical products directly from CAD. Of course, CAD stands for Computer Aided Drafting and Design. So we take the files that are designed in CAD and we can create the files that are needed to go direct to a printer and 3D print directly from those. It is largely used for prototyping and proving out those designs, making sure that all the parts come together for fit, form, and function, and that they do function as intended before we actually go into mass production on those. It's often used because it's cheaper than conventional manufacturing practices of the past, where all of those parts would be done in like a tool room or tool shop by highly skilled and trained machinists to basically make every part first and then assemble it to make sure and prove it out before actually going into mass production on the parts. In this case, a lot of that can be done, and we can prove a working concept before just by printing out the product and taking it off of the 3D printing machines. It also requires a lot less tooling and less complex setups or machine time in order to achieve that as well. So as we continue to improve on our materials, as we continue to improve possibles or improve processes, it is possible in the future that we could eliminate several of these manufacturing processes or no longer have a need to produce parts in that way. And of course, that is one of our goals as we try to streamline our manufacturing setup. All right, so let's kind of go over some review questions here for Chapter 10. If you think about the question here, so I'm asking you to identify the 5 casting and molding steps. So if you go back and stop and think about it, um, those 5 steps include number 1. First, we have to make the mold, and then we're going to prepare the material. Once the material is prepared, we can fill the mold. The material has to harden, and then, of course, we can remove that material from the mold as well. So, those are the 5 steps to casting and molding. Which casting process would be used to cast really large parts? So, well, if you think back about that, this is probably one of the cheapest methods, especially when we are talking about huge parts, and that is sand casting. Which casting process is also known as the lost wax process? Well, if you think about what the lost wax process was, that was where wax might be used. We create a part in the shape using wax. So, and then we would form the mold and around that. So we heat that up and let the wax melt out, and that is what we would refer to as investment casting. So investment casting is also known as the lost wax process. Which casting process is used for ceramics? So if you think about that, that would be slip casting. And remember that a slip is a slurry of our ceramic type materials and water. So kind of a particulate slurry there that would be poured into a plaster cast. The plaster absorbs some of that moisture, and then we would kind of pour out the remaining slip and be left with some of the ceramic that would then get fired up in a kiln. So just as a refresher on the slip casting process. Which casting process is used for a really large number of parts? So if you think about that, think about your Hot Wheels or your Matchbox cars, where we're basically manufacturing hundreds of thousands of these every year, and that is the die casting process. Of course, I mentioned Hot Wheels and Matchbox cars, but there are a lot of other parts that are made using die casting. Going on now, we've got a couple of questions here to help prepare you for the MSSC certificate. These are the test prep questions. So if a part is to be good quality, the type of mold must match the properties of the materials being cast or molded. Sand molds are used for shaping parts made of. So, well, if you think about that, that would be made of metal. Metal would be the answer there. Process used to form a metal part depends on the shape and complexity of the part. Open die forging is generally used for parts that are. So if you think about this, the answer to this particular question is large and have simple shapes. So open die forging would be generally used for parts that are large and have simple shapes. Net shape manufacturing produces a part or product with only one process that needs no additional trimming or shaping. An example of a net shape manufacturing process is, and your possible answers here are metal injection molding, plastic blow molding, metal extrusion, or metal casting. And the answer is metal injection molding. MIM was what we call that. Metal injection molding is a net shape manufacturing process. All right, so there is the end of our lecture on producing products. So go ahead and review this, go back into the PowerPoint, watch some of those different videos that I gave you, and make sure that you understand everything we're going over in this chapter.